Hello, everyone. Not sure who is online. It's my first time for doing this a live streaming broadcasting, uh, but it's our first attempt to starting a weekly live streaming um, about Pulsar. The idea is called TGIP, TGIP, uh, TGI Pulsar. TGI is short for thank God it's Pulsar. I think it comes from the thank God it's Friday, and we host this weekly live video streaming every Friday and talking about Pulsar. And um, sorry, I forgot to introduce myself. My name is Sijie, and I'm currently the co-founder and CEO of StreamNative. And StreamNative is a company that providing a cloud-native event streaming platform powered by Pulsar. And I'm also the PMC member of Pulsar and BookKeeper. So I have been working on Pulsar for many years. And my team is also helping a lot of people adopting Pulsar. So we have many years of experience running Pulsar production. And the idea here about TGIP is to having a platform for like every week we can jump into a live streaming to talk about Pulsar. And here's the website. There's a GitHub repo that we use for hosting every episode's content. If you want to check out all the content, you can go to StreamNative/TGIP, and you can create issues to suggest any topics that you are interested, and we'll find PMC member, a committer, or possible end user to jump into the live streaming to talk about that topic. So let's start it. So for the first episode, we are going to talk about the install a Pulsar cluster. And I know like uh, people when want to try out installing a clusters, they would just go to Pulsar website and just find a section that maybe deployment and then find an environment you want to start following the instruction to start. But sometimes uh, people usually quickly hit the problems is because they don't quite understanding how Pulsar is working and what are the kind of a dependency and especially what kind of the requirements between different components. So every time when you start installing a Pulsar cluster, I would actually thinking uh, starting from some of the simple principles. Uh, I always have three principles to suggest to a lot of people who is the first time Pulsar user. The first one is when you try to deploy a cluster, try to deploy a minimum set of clusters. Don't try to deploy a cluster with every features enable. Like don't try to enable TLS encryption. Don't try to enable authentication. Don't even try to enable functions or any other components. Just pick the minimum of the components before you understanding better of the system to enable other features. And the last thing I usually suggest is before you deploy a cluster, especially Pulsar is multi-layer architect system. So they have many different components within the Pulsar cluster. In order to have a better experience of installing clusters, try to figure out what is kind of the network topology between the component. Then you have a big picture before you installing a cluster. And I think that has been one of the problems that I in inconvenient experience that people would hit when they try to follow instruction to install a cluster because they don't have a big picture about what is the network topology will look like for a cluster. So before we going into uh, do some exercise or demo about how to deploy a cluster, I will actually go through some of the basic to talk about some of the dependency between the component of a Pulsar cluster and some of the network connectivities between each of the components and following by startup sequence. So once you have an idea about this dependency and network topology, you would have a better idea how I should install deploy a cluster. So I actually draw a simple diagram to first give an overview about what kind of the dependency between each other. So let me walk you through one by one. So, okay, interesting. I have this, okay, here. Okay, so at the beginning, I mean, everyone might already know Pulsar need a zookeeper. The zookeeper cluster is used for service discovery. So both broker and bookies need to register themselves to zookeeper. It's also used for metadata storage. So first thing you would have a zookeeper cluster, and the cluster is exposed at the service port 2181. And once you have a zookeeper cluster, the second thing is you would have to set up a bookkeeper cluster. Uh, the storage node in bookkeeper is called bookie, and you can deploy as many bookies as you want. Usually, starting from a minimum size of the cluster, people will start with 3 bookies. And each bookie would expose its service at 3181 port. So this is the service port that for bookkeepers clients to talk to bookies. So once you have the bookies, one thing you need to realize is the bookies need to talk to zookeeper because it has to register itself to zookeeper for bookie discovery, and it also have to access the metadata stored in zookeeper. So you need to make sure bookie is able to connect to zookeeper before you start bookies. So once you have bookies, then the next component is actually the messaging serving component, which is called broker. And broker is exposed its service at 2 ports. One is an HTTP admin port at 8080, and it exposed the data port, what we call broker service at 6650. And these 2 ports are exposed to the clients to talk to brokers. And once you have the broker components, you need to figure out how broker talk to bookies and how broker talk to zookeeper. So first thing you have to make sure broker has connectivities to zookeeper, and because broker using zookeeper as service for broker service discovery and as well as the metadata storage. So broker has to talk to zookeeper. And the next thing is, since broker itself doesn't store the data directly, it's actually storing the data on bookkeeper. So the broker itself need to be able to connect to bookies through 3181 port. So broker need to depends on bookies. Um, so there's kind of dependency here is broker need to wait bookies to coming up, but how many, or do you need to wait the whole cluster to coming up? Usually the requirement is just achieving the example size you config for the broker. So if you configure example size to be 3, just make sure you have 3 bookie available, and the broker is able to write the data to those 3 bookies. So that is kind of the minimum requirement. So once you figure out the broker has broker depends on ZooKeeper, broker depends on bookies, and they have both network connectivities, then you already have a minimum viable cluster to be able to serving your client. So your clients, like you can have a producer, and the producer is able to talk to the broker at its at both port, like 8080 or 6650. But the most important one is you are able to connect to the broker part, that is the 8860. And you can have a consumer. Consumer is also talking to broker, and it should be able to connect to broker on port 6650. So that is the kind of give you an overview about how a cluster, a minimum set of minimum viable cluster would be available for serving the producer and consumer. You just need a ZooKeeper. You need a set of bookies, depends on the example size it config. You just need a broker, so you are able to providing the service to your client. And to better understand the uh, kind of the cluster deployment, I would actually recommend drawing a diagram about how the machines would be talking to each other. And this diagram is very useful for deploying a cluster, as well as for you figuring out how to config a TOS encrypt cluster. So if you want to make sure the connections between all your components are TOS encrypt, you have to understanding like how each component is connecting to each other to be able to configure those settings. Same apply to authentication and authentication and as well as authorization. So usually, um, when as a starting point, I usually suggest people to try out a small set of cluster and try to understanding the dependency between the components and laying out a network topology between each component. And once you laying out in a network, that topology could really be helpful for you to understanding. First thing is if I have configured the cluster correctly, if the connections is able to config in the TOS encrypted way, and how I can enable authentication. So let's go through this process one by one. So first thing, you would have a ZooKeeper cluster, and you need to understand here is for ZooKeeper, what you expose to the client is a client port called 2181. But within the ZooKeeper cluster, it actually used two other ports to communicate with each other. Those two ports are leader election port and follower port. And the leader election port is used by the ZooKeeper servers to communicate with each other to leader election. And the follower part is once a leader is elected, the followers would following the leader to receive all the updates and as well as snapshot from the leaders. So you need to make sure the Zookeeper server are interconnect with each other through those ports. And Zookeeper is able to provide port listening on 2181 for your broker for your bookies. So once you have Zookeeper up running, then you can move to the next step to config bookies. So once you have the bookies, then you need to first figure out the thing is the bookie itself need to be able to talk to Zookeeper. So you have to know how to config your bookies to talk to Zookeeper and how to expose your service to your broker to other components within a Pulsar cluster. So I would stop here and then let's walk through some kind of demos to understanding those settings like component by component. So I actually have apps as a materials provided in the kind of the episode 1, and it's under this markdown file called demo. And as you can see here is I have copied the Pulsar configuration here to prepare the demo. But so if people follow the instructions in demo, you should be able to run the same setup as me. So the first thing is for this demo, for this walkthrough, I would use the Docker to set up a cluster. And the first thing I want to try here is first I would create a network called Pulsar, and this is a Docker network that would be used by all the components that running within this cluster. So let's see. I would create the first network. Oh, I already have a network here. So let me do network ls. Here you go. We already have a Pulsar network here. So in this demo, I'll just simplify the process. I'll just create one Zookeeper node. But if you want to create multiple Zookeeper node, you can follow the Zookeeper instructions to follow the documentation to deploy a Zookeeper cluster. So first thing, I'll create a directory and for storing all the Zookeeper data. And once I have the directory ready, I can run a Docker command to start a Zookeeper server in the background. Okay, I have some issues about the, oh, sorry. Oh, I need to expose the person network here. So it's able to use the network to start the service. Okay, so the Docker should be container should be running, and so when you deploy a Zookeeper cluster, you usually want to verify if your Zookeeper cluster is up running. A few quick things you can do is uh, the first quick thing is usually just check out the logs to see if there's any errors. If there's no errors, then most likely the Zookeeper service is also up running. So as you can see, it seems like we are good, are in for logging, so we're good. And if you want to check if the service is healthy or not, you can telnet the Zookeeper service on 2818. Zookeeper offer a 4-letter command, so you can use the for-letter command to check the healthy of a Zookeeper service. The first, the most common one is the command called "Are you okay?" So when you send a "Are you okay?" command to Zookeeper, if the service is healthy, you will receive "I'm okay" response. Otherwise, you will respond some other error messages. So let's see. Let me turn that to the because I already exposed the Zookeeper service, the service port 2181 to my local 2181 port. So I'm able to just telnet the local 2181 port. Sorry, I think it's timeout. Are you okay? So as you can see here, you will be receiving I'm okay. That means the Zookeeper cluster is up running healthy. So once you have the Zookeeper service up running, the next step before you deploy bookies, you want to initialize what's called a class metadata. The cluster metadata is initialization is mostly just creating some Zookeeper paths. Those paths would be used by both bookkeeper and brokers to storing their metadata. So if we want to see how the initialization happens, we can, for right now, we can just go to the Zookeeper Docker and to see what's exactly stored in the Zookeeper cluster. So let's just see. I have the Zookeeper running. I can go xcc dash go to the Zookeeper container, run bash. So I'm get into the Zookeeper container. So I'm able to run Pulsar Zookeeper shell. So this is a very convenient shell to provide for Pulsar for you to connect to Zookeeper to check to run the Zookeeper command to check the informations stored in Zookeeper. Okay, so now the Zookeeper shell is up running. Then you can just, because it's a tree structure, so you can just use a lot of command here. If you don't know the command, you can just run help, and it will listing out all the available commands in this Zookeeper shell. So as you can see here, there's uh, there's only one Z node under Zookeeper right now. It's used by Zookeeper itself to store some metadata itself, like its own config, its quota. So that is not the Z node used by Pulsar. So once we have Zookeeper ready, before deploying bookies, you have to initialize the cluster metadata. And Pulsar already provide a command called initialize cluster metadata, so you can just run the command. So I will run the command in my Zookeeper server. So let me export some environment. So I need to, I can just type copy the command. Uh, as you can see here, the command is basically asking a few information. The only kind of required, it has to be 100% correct information here is the BookKeeper and the configuration star and cluster name. The web service URL, web service URL, TLS, in the broker service URL, broker service URL, TLS, those are kind of the service URL for your cluster you want to expose to your clients to be used. But those settings are kind of only useful if you set up multiple cluster replication, aka geo replication. If you don't have those, if you don't know how you want to expose the cluster at this moment, so you can just leave the you can just even put some local host 8080 layer. It doesn't impact you for using a Pulsar cluster because you can update those URLs in future using Pulsar admin to update those cluster configurations. The cluster name has to be correct is because that would be the cluster name you used for config your brokers. And so in this example, I'll just use class 0 as my cluster name. And in next a few steps, I would configure a broker called class 0 dash broker 0. So I would use that broker as my service URL. So I just put the service URL here. And the initialize work would just create all necessary BookKeeper paths on BookKeeper and creates a cluster called cluster 0 with its web service URL. And I can walk you through about this after this command is executed. Since we don't deploy a global cluster, so we just put the BookKeeper in configuration star using the same BookKeeper cluster to start. So you will see the class metadata for class 0 is set up correctly. Then we go back to check what has been created in BookKeeper. So that's ls the root path. So as you can see here, it create a lot of Z-node under the BookKeeper server. And some of these are used by bookies. So the ledgers is used by bookies. So all the BookKeeper metadata would be put under /ledgers. And manage ledger is actually the metadata for storing the metadata for kind of each Pulsar topic partitions. Each topic partition will use a managed ledger, and the managed ledger will recording the list of ledger used for storing the messages. So this is the managed ledgers. And there's no topic created, so there's no managed ledger created. If you check here, the namespace is used for storing the namespace for namespace in the topic and other subscription related informations. And the stream is actually used by the state storage. You can see here is for the BookKeeper table service, and the bookies is used for setting up a record-aware placement policy. So you can register your network topology for individual bookies under list node, and you will have other information under admin. In admin it would including a bunch of the information like the clusters and also the namespace policy and the partition topic metadata. So as you can see in the Initialize, we provide some of the web service URL and also provide a cluster name, and that would be created under this admin clusters. So you will see we create a cluster 0. And if you are interested in what exactly is stored in the cluster 0 znode, you will see it's actually the cluster configuration. And let's check it out. So you can see here, it's JSON, and the JSON is for representing the cluster configuration, and it has 4 service URL, and those 4 service URL are provided by the initialize command I use here. So if you remember here, when I initialize cluster, I provide 4 service URL, and those 4 service URL would be stored as a cluster configuration and stored in BookKeeper. So next time when you reference the cluster name, the Pulsar would just use these 4 service URL to talk to the cluster. So if you are using TLS, they would just use TLS service URL. If you are using non-TLS, then you just use service URL. So that is the initialization. So initialization is basically creating all the metadata znode in BookKeeper and create a cluster and set the cluster's configuration. So that is the initialization part. Once you initialize the cluster, then you can go ahead to start the bookies. So in this diagram, as you can see, the bookie itself need to talk to BookKeeper. And so when you configure a bookies, you need to figure out how to configure the BookKeeper server, and so that bookie know how to connect to BookKeeper. So in this demo, I would just create like start one by one, and let's create the first bookie, and I'll create 2 directory for storing the data of the bookies and storing the data from the for the logs. And so I would use the I have actually create a configuration directory for storing the config for the list bookie 0. And if we check this bookie 0, you can see here is cluster 0, bookkeeper 0, and this is the kind of minimum set of the files you need to config for starting a bookkeeper a bookie. So when you want to start a bookie, you need to config how it connect to BookKeeper. So it has to be there's 2 settings called JK servers. This would determine the BookKeeper clusters that bookie can connect to. So you have to set the JK servers to be the BookKeeper's cluster. It has to be the BookKeeper service, sorry, domain name, column, its part. Or you can animate the port, because the BookKeeper client would autofill the port. And the other settings for quick start is make sure by default the bookie port is listening on 3181. If you want to change port, bookie port is the one you want to change. And the next one is the general directory. That is the directory for putting the data in putting the general data on the disk. So you need to if you want to use a separate disk, you have to make sure the general directory point to the right uh, directory that the disk is mounted. And the next one is the ledger directory. Similar thing, you need to make sure this directory is configured to the right directory you want to use. And those are kind of the minimum setting you need to configure in order to start. And so I already have the config ready. Then I mount the my local directory that I just create a data class 0 bookkeep 0 to the path slash Pulsar slash data slash bookkeeper. That is the directory I used for storing the journal in ledgers. So I have everything ready. I have the right disk. I have the right configuration. I export the port. So I'm able to run this to start a bookkeep. So when you start a bookkeep, similar thing, you want to do a healthy check before you move to the next step. The simple thing you can check is still check the log. So let's check the container. That would be class 0, bookkeeper 0. So we see it's that component bookkeep server, and it means the cluster is running okay. And as you can see, I mount my local directory data cluster 0 bookkeeper 0 to the container as its journal in ledger directory. So if I go to these directories, I should be able to see some of the files are created by this this bookkeep. So it would be data class 0 bookkeep 0. So you can see it's actually have the general directory, and I have a bunch of files. It opens up the first transaction general file, and I have a version there. And if I check the ledgers, I should have the same thing. I have version last mark, and I have the directory for storing the ledgers in ledger index and location index. So that is uh, the bookie. So we have checked the log. We check it's actually open some files to write. And the next thing you can check is it actually if this bookie is registered to the Zookeeper cluster. So if you, as I mentioned, all the bookie metadata is stored under slash ledgers. And if you go to ledgers and available, you should able to see, okay, there's a cluster. So there's a bookie registered under ledgers slash available. And the available is used for keeping the list of all the writable bookies. And there's a Gnode called read only. Read only is used for the keeping the bookies. Those are in read only mode. But because we don't have bookies in read only mode, it just shows no does not exist. And the so why there's a read only mode is bookie usually would turn itself to read only when it reach a certain threshold. When the disk reach a certain threshold, like for example, by default is 95%. If your disk usage is up to 95%, it means you are approaching the capacity of a disk. Bookie would turn itself to read only, and once the bookie in read only, it can continue serving the read traffic, but it would not be able to write data But Pulsar is a segment-based architecture. The broker can move on to pick up a new writable bookie to write. So you don't need to worry about disk space really fill up. So this is just a side note. Go back to you need to check to make sure the bookie is actually up running. What you can also do is use a command called simple test, because right now we only have one bookie up running, so you need to specify the sample size as one. Otherwise, you will not able to create any ledger to do the test. So let me go to the bookie cluster. Cluster 0, BookKeeper 0, and run the command. And the simple task is basically try to open a ledger and try to write bunch of the entries and close the ledger and delete the ledger. So you will see it says it write 1,000 of entries to ledger 0, and that means I'm able to successfully write the data to bookies. Then the bookies is up running normally. So once you have one bookie to start, it depends on the sample size you config or the number of replicas you want to use. If you config a sample size to 1, you can move on to deploy the brokers. But if you config a sample size to be 3, so you need to make sure you have 3 bookies up running. So I would do a quick operations to create another 2 bookies. So it's the same command, just a different Docker name, and I will check the healthy later. So I start 3 bookies. They are all running. Then I go back to the first bookie's terminal, and I can use this the script provided by the Pulsar distribution called BookKeeper. And in BookKeeper, there's a shell, and the shell is basically providing all the tools for operating or checking BookKeeper cluster. A few things we can use the shell to check is the first thing you can use shell to list the number of bookies up running in this cluster. So if I run shell list bookies, I need to give yeah, I think I need to give dash r listing all the bookies. So you can see all 3 bookies is registered into the cluster. You can also see read write and read only. So there's no read only, it will show no bookie exit. And you see there's already 3 bookies, and if you want to check all 3 bookies are actually running, you can just create a sample with 3, and right column with 3 is basically a column with 3. It just means you are trying to write to all 3 bookies and wait the response from all 3 bookies to ensure all 3 bookies are running correctly. So let me just run this command. As you can see, it successfully cracked to 3 bookies, 0 and to 1, and successfully write 1,000 entries. So it means all the bookies are ready and to serve the traffic. Then you can move on to the next step. But before moving on to the next step, I want to call out another component. that is called auto recovery. Auto recover by default, if you don't run any auto recovery, you don't the bookie itself doesn't need any interconnectivities between bookies, because in the bookie the replication model is a bit different from other like leader follower replication algorithm. So there's no actual leader within bookie, though they are all equally same. And so that they are both able to serve write in read. So you're able to actually scaling out write in read by just adding more bookies. I want to call it out here is because we need to run an auto recovery. And auto recovery can either run outside of the bookies or enable to be running as part of bookies. So when you want to, we think the auto recovery as a logic unit, the auto recovery need to be able to connect to Zookeeper, and the auto recovery need to be able to connect to bookies because it has to replicate the data and from one bookie to the other bookie. So the auto recovery need to be able to connect to both Zookeeper and bookies. So if you just enable auto recovery running as part of bookies, because you already configured Zookeeper server, auto recovery will just using the same Zookeeper server setting to connect to Zookeeper. And once it connect to Zookeeper, it will discover what are the available bookies in the cluster and do monitoring those clusters and replicate the data. But you need to make sure the bookies and bookies, the interconnections between bookies are be able to connect it. So one bookie is able to talk to another bookie on 3181 port. That is when you enable auto recovery as part of bookies. So once you have the cluster running, you can actually move on to deploy a broker. So deploy a broker, you need to first figure out what kind of the service you want to expose to your public client. So whether you want to enable TLS or not, or if you want to use a default port or use a different port. So you have to figure out the port for each brokers that can be used by the clients to talk to. And then the broker need to be able to talk to Zookeeper, uh, and the broker need to be able to talk to bookies. In term, you don't need to directly config the bookkeeper bookie address in broker, because you can discover those bookies from Zookeeper. But you need the network connectivities between broker and bookie. That means if you have a broker running here, the broker should be able to talk to a bookie through 3181 port. And that is the kind of the requirement. And also oftenly one thing is usually missed is the broker to broker communication. For some admin request, the broker need to talk to the other broker. A simple example is if you running the admin tool to listing out the stats for a partition topic. That means the broker who's serving this HTTP request, it has to go to other brokers to collecting the stats for individual partitions and aggregate the result to respond back to the client. So broker needs the interconnectivities between each brokers. So that is the thing is that is the kind of minor difference between a broker and bookies. So you need to make sure broker is also able to talk to the other brokers. So let's see how we can configure a broker. So if you want to configure the broker, it's all under broker. You actually just need to configure the ZooKeeper server. The ZooKeeper server is used for both broker discovery and also as well as bookie discovery and also the metadata. So the BookKeeper cluster and the broker cluster is kind of sharing the same ZooKeeper cluster. So you just need to configure the ZooKeeper cluster, then you are able to discover both brokers and bookies. And since we don't deploy geo-replicate cluster, so we just make sure the configuration store servers is the same as the ZooKeeper server. And you can configure this port to for the service you want to expose to your client. If you just get started, you can just leave as default. And the other most important one is configure the cluster name. That means which cluster that the broker is running. That is important is when you send a broker, so you want to publish a message to a topic, it has to check if this cluster is in the allowed cluster list of our tenant. If it's not in the allowed list, then you would not be able to publish the message to that topic in that cluster. So you need to make sure the cluster name is the same that of the cluster you want to deploy here. So once you have these settings set, you are ready to move on to start a broker. So I would just use this command to start one broker first. And I can start another broker. So similar thing, you can check the logs. So okay, as you can see here, postal service started. That means the broker is up running. If you want to make sure again, you can go to the ZooKeeper metadata to check the load balance. Sorry, I must mistypo. Now you can see here, they have a bunch of the information here. If you check the load balance brokers, you will see I have the two brokers up running. And for like a broker healthy check, I usually just do Pulsar admin to listing out some of the information. That would be helpful. So let me just go to let's see, broker 0. So if it's able to return the list of tenants, and it usually just means the service is up and running correctly. But as you want, you can also use a command called house check under the, is it broker or brokers? Actually, yeah, brokers. So we have a command called health check under the brokers. You can run this health check command to check the healthy for a given broker. And what it does is basically produce to a system topic and try to receive the message to make sure the end-to-end is running correctly. So we we already have all the kind of a minimum set of the cluster up running. But as you can see, all this kind of running within same Pulsar network, same Docker network called Pulsar, and they are able to connect to each other. And if you are deployed on an on-premise environment, you just need to make sure if you deploy components into individual machines, these machines don't have any firewalls between each other. Make sure they are able to connect through the port that you specify. And if you are running in container environment like Docker Swarm, or Kubernetes, if your application is running within the same environment, you don't need to worry about expose your service, because your service in your Postgres cluster is on the same network. But if you run, for example, if you're running on Kubernetes, but you have application running outside of Kubernetes, you want to accept, you want to let your application to talk to your cluster, you need to set up a proxy. That proxies will be serving as most likely it's a topic ownership aware TCP proxy. So you are able to send the request to write broker. And since due to time limitation, I will not cover proxy in this section, but I'm happy to talk about installation in a container environment, in Kubernetes environment in a future episode. And this diagram I just showed is very important. It's not just important for for the initial setup, but it's also important if you want to config TLS encryption between each component. You really need to understand like how each component talk to each other in order to set up the fully TLS encrypt cluster. And similarly, if you want to configure authentication and authorization, you also need to understanding the dependency between each component. So make sure you kind of having a similar diagram in place, and that would help you do config TLS, authentication, authorization, and even troubleshooting on production. And I actually upload all the files I used into TGIP episode first episode. You feel free to download those XML files or monopig files if you want to edit, or otherwise there's already generate PNG for people to use. And will be the first kind of the episode. And since I don't have a dual monitor, so I'm not able to check if any comments or live chat. I'll probably uh, find another monitor so I can do a live chat or live interaction with people next time. But thank you, everyone, and hope my sharing is helpful for you to understanding more deeply about Pulsar. Especially, it would be helpful for you either to get started, to configure the cluster well in production. Thank you, everyone. See you in next episode, and happy Friday, happy weekend.